So this is part 2 of buffers. In this clip I'm going to talk to you about how a buffer pH will change with the addition of a strong acid and a strong base. So first of all, with the addition of a strong acid, notice that the buffer's already been set up in this question. So we have the weak acid, we have the conjugate salt. 15 cubic centimeters of 0.1 molar HCl is added. This is the equation. So the HCl reacts with the salt, forming the carboxylic acid and the sodium chloride. We're not interested in sodium chloride moles, it doesn't affect the pH. Let's look at then the ICE table. So the I is the initial moles of chemical. So 0.15 is calculated by 1 dm cubed multiplied by 0.15, so N equals C times V gives 0.15 moles of sodium ethanoate. Then we've got the HCl, 0.015 multiplied by 0.1 gives 0.0015. And then the weak acid, 0.1, because it's 1 multiplied by 0.1. The HCl is the limiting factor. This is the smallest amount of moles, so we subtract by this value. We also need to subtract the salt moles by this value because those two are reacting. So we have the end amount there of the salt, which is 0.1485. On the right hand side, the acid will go up in value by the same amount, the seesaw effect, down this side, up this side, and so the final value there is 0.1015 for the weak acid. Once we've got our moles, we can then start thinking about the calculation to work out H+. So we're going to use Ka equals H plus times by the salt concentration divided by the acid concentration. Put the numbers into the equation. There's the salt, there's the acid. This is the total volume calculated from 1 plus 0.015 for the acid. But then I've crossed through the volume because they cancel. We then rearrange the equation, so H plus is the subject, so H plus is Ka times by Ha divided by A minus, and so that gives us 1.19 times 10 to the minus 5. pH equals negative log of H plus, so it's 4.92. Now calculating the pH of a buffer with the addition of a strong alkali. Same scenario, we've got the buffer set up, we've got the weak acid moles calculated, the sodium ethanoate moles calculated using N equals C times V. I've calculated the number of moles of sodium hydroxide. The Ka is the same. I've got to calculate the pH of the solution after the reaction. In the reaction, the sodium hydroxide reacts with the weak acid, making salt and water. The sodium hydroxide is the limiting factor. We will subtract by this amount. On the left, there's 0.1. Subtract the NaOH amount, leaves us with 0.0985 moles of the weak acid. The salt has gone up because it's the other side of the equation, and we end up with 0.1515 moles of the sodium ethanoate. Then we're going to work out pH of the buffer solution after the reaction, so we use the Ka expression again. We put the numbers into the equation. There's the salt moles, there's the acid moles. Like the previous example, cross out the volumes, they cancel. Rearrange the equation, so H plus is a subject, so it's Ka times by Ha divided by A minus, gives 1.13 times 10 to the minus 5. pH equals negative log of H plus equals 4.95.